All right. So, this is the, give me 1 second. Okay, so this is, the movies lab. There's really just like I think there's two main points I wanted to bring up, all right? So the first is, so we have these movies, you can kind of see, right? We have actors, directors, movies, writers, right? Movie actors, and then these three. So if you think about it, what really joins everything together is probably like the movies table, but not, like conceptually, I would say. For each of these, we really have like a many to many relationship, right? So in other words, like a movie has many actors and an actor has many movies, right? A director has many movies and a movie can have many directors. So in terms of the tables that you're really thinking about, it's these three, right? These are our join tables, and at least it seems like that. And these are the ones that have like the foreign keys. And you can kind of even probably guess like what are the foreign keys here. Like we have, like for movie actors, like what is probably the foreign key? Well, it's probably movie ID and actor ID, right? And then for movie directors, it's the same thing. It's probably going to be movie ID and director ID. Okay, so you can kind of just like, okay, like what you want to do, I think, is start to summarize in your brain, like how is this database structured? And you're kind of thinking, well, everything, we have this movies table in the center, and then in between the other entities is a join table, right? So it's like movie has many actors through movie actors. And what's linking up these tables are the foreign keys, right? The movie ID to the actor ID, right? So even though there's 6 tables here or 7 tables here, you can really start, I think, to like summarize it. Okay, so then the other thing is, now let's try to answer some of these questions. What is the name of the writer in the database that has been credited the most times during the year 2018? Okay, so what's the name of the writer credited the most times in the year 2018? So it's like, what tables do you probably need? Well, probably movies, writers, and then we want to link these two with the movie writers. That's what I'm thinking, right? Why do I say that? Well, writers is obvious, right? That's where we're going to get the like when you're thinking about what you need to load, you're thinking about what columns are needed. So if we need like the name of the writer, well, that's on the writers table. And then here, this is the where clause, right? And that's going to be, here we need movies from the year 2018. So that's in the movies table. And then we need to link up these two tables. So that's probably this movie writers table. All right? So now the next thing, so now we start to do it. And I would just start with select all from. And now, so just to summarize, we know we need movies, writers, and movie writers, right? So select all from, and you can kind of start wherever you want. I generally start from we'll start from movies. So select all from movies. One thing that's kind of important is to think about like the dimensions. By that I mean like how many rows are returned with each query. So if you do select all from movies, you're going to get back 1 row for every movie, right? So I guess there's like 15,000 movies in our database, right? And we're getting back 1 row for every movie. Now, how do we get the next thing loaded? Like, how do we load up the next table? We can't go to writers, I don't think, right? Because writers doesn't have, like we have these columns of movie, namely we have this ID, right? That's really the only foreign or primary key we have is ID. So we need something that references like movie ID. And that's going to be this movie writers table. So the next thing you want to kind of think of is like, how do you connect what is currently loaded into memory? So right now you're loading the movies table into memory. So it's how do we connect what's currently loaded into memory to the next table I need, right? So the only way you can get to another table, I think, is by linking this ID column to the movie ID column in another table. So that would be here. So we're going to join, and when you join another table, right, you're loading it into memory. So now we're going to join movie writers, and it's going to be, and what we want is we want to align the rows where this movie ID on movies.id equals movie writers dot movie ID. In other words, like we want to align the rows where this movie ID column equals the movie writers, has it also movie ID. So we can kind of see that. Let's just do like limit 10 or something. So what are we looking for? We're looking to see that this ID here equals this value here, right? That's exactly what you're specifying here. Movies ID, the primary key of movies, equals the foreign key over here. All right. So that's kind of the first point is what I'm thinking of when I'm joining these tables is, all right, I'm starting with this one table into memory. How do I get to the next table? How do I load the next table into memory? You have to connect them. That's what this component does. It says, hey, I already have this table, this column ID, and I want you to, and we can join this table so long as we connect it to another column, right? So we're linking our data by linking this column here to this column here, right? And now that's kind of aligning the data. So the point, like what I'm trying to get you away from doing is like trying to memorize stuff. I really want you to understand why each statement is necessary here. So load this table into memory and set the values, align the rows such that this value here lines up with this value here. That's what this part is doing. Okay. The next question is, once we go from, remember we started with select all from movies, right? We saw there was like 15,000 movies in our database. Once we join this other table, do we have more rows or fewer rows, right? I mean, we can count it. We could say like select count star to see this. You can see we have more rows, right? Right, and this makes sense because each movie has many, has many writers, and we can see like a movie repeated multiple times, one for each writer here, So if we let's order by movie ID. Descending, limit 10. So you can see an example here, right? We're repeating, when we do the join, we're repeating this 3 times, one for each of the writers here. So this 29708 is linking up, right? Multiple times, once for each writer. So, it's important to keep in mind the dimension here. And now here's the next. Okay, so what is the name of the writer that has been credited the most times during the year 2018? So let's take this out. So we have the movies, we have movie writers. The next thing we can do is kind of say, let's just limit our data set to those where the movies.year equals 2018. So the where clause occurs first. We have all these rows, basically all the movie writer roles in the database, right? And we saw there's a lot of them. But now we're going to scope down our data to the year 2018. Okay, so these are just, movie writers that wrote a movie in the year 2018. And then we want the writer that has been credited the most. So how do you do this? So basically we have this data set. We have this existing data set. And now we want to put it in groups based on what's the writer ID, right? Because we want to count up how many times has each writer appeared. So now we're going to do the group by. So I would group by the writer ID, or you could just group by, writer ID is fine. And for now, we can just select the writer ID, comma, count, star. So this is you know, if you think about it, what we're starting with is movie writers in the year 2018. Then we group by the writer ID. So we put into groups one for each of the writers that show up. And then we count how many entries are in each of those buckets, right? Like how many rows are in each of these groups by the writer. And we can order by, let's say like as count, order by count descending. And so we can see that we have at least one writer that did this 3 times. And then a couple that did it 2. And that seems about right. You know, like in my brain, I'm kind of like logically checking for it. And it's like, okay, well, this is just the year 2018, so 3 sounds like a lot of times, a lot of scripts to have put out in 1 year. Right? Okay, so then the last thing is probably just to find out who is this writer. So what you should be thinking about is, well, how do I get to that column, like the writer's name column? And again, we need to load the writers table into memory. So currently we have the movies table in memory. We have the movie writers table in memory. The next kind of table to link to, so we have movies. Like I'm thinking of, in my brain, I'm thinking like an arrow. You know, we start with movies ID here. And then we were able to get to movie writers by connecting movie writers.movie ID. And now the next goal is to get to the writers. And we can do that. How do we do that? Well, by joining writers on movie writers dot writer ID. You know, because we already have this table loaded into memory, this movie writers table. So the next thing is to get to this writers table by using the movie writers dot writer ID column. So join writers on movie writers dot writer ID equals the writers dot ID. Okay, so everything is, again, it's like very purposeful. How do we load this table up? We want to link this existing column, this column that we've already loaded into memory, to this new column, right? This column on this new table, writers. And now why do we want to do that? Because we want to get the name. So that'll be writers.name. And you could like, and we see that we got the right guy. You know, we could limit 1 or whatever. You know, just limit 1 to get down to the first row. Okay. One thing when you get to Postgres, Postgres has a restriction where basically if you do a group by, you can only select the column that you group by or have an aggregate. So this may break. I think this would break in Postgres. So you'd have to do, if you want to see the writer's name, you would have to do, probably have to do group by writers.name. That way you can see it here. You know, or if you want to see both columns, you could do, you could probably do this, group by writers.name, comma, writers.id, and then select writers.id. Let's move this out in front. So this is creating a group like based on this tuple, based on the writer's name, based on where these values are always going to align though, generally, you know, like each writer gets a different ID. Oh, maybe I can't do that. Row value misused. Comma, count star, as count. Let's see if I have to take this out. Okay, we got it. Yeah, I just couldn't have the parentheses around here. All right, so what were like the main things I wanted to emphasize here? One is the, you know, thinking about like the dimensions of the data, right? We saw that we started with just, select from movies. Like when we did select all from movies, we had one row for every movie. That was like, 15,000 movies. Once we did then the join movie writers, now there's, we're increasing this. Like the dimension changed because now it's one row for every writer of a movie. Okay? And then finally, we limited down the data once we did a where clause, right? Where movies.year equals 2018. So now we have fewer rows. So it's every writer. And what are the rows now? It's every writer, every kind of row in this movie writer in the year 2018. And then finally, once we do the group by, again, we're changing the number of rows returned because we're grouping by movies dot writer or movie writers dot writer ID. So now it's now it's just one row for every writer in the year 2018, whereas before this grouping, we would see each time a writer wrote a different movie. So this Ryan Engel would have been listed. We would have seen all three rows separately. Once we do the group by, right, we're kind of consolidating that writer into one entry, right? So like thinking about the dimensions and like kind of having that in your head is really valuable. Then the last point is just like you're linking, you're kind of justifying when you're joining these tables. It should be pretty purposeful. It's like, think about, all right, I'm starting loading the movies table into memory. How do I get to the next table? Well, it's by linking columns, right? This column that is already in memory to this new column, right? To the table I want to get into memory. So movies.id equals moviewriters.movieid. The last thing is the order of this matters. Like you have to put the where clause before a group by. If you don't, it's going to break. Okay. And it makes sense. Like logically, it makes sense. The where in SQL occurs before the group by. Like first, you're going to limit the data set down to movie writers from 2018, and then you're going to put that data into groups. Okay. A having clause should really only be on an aggregate. Okay. So what's the aggregate? Count. Right? So you can say, so in other words, I wouldn't do like having year 2018 because nothing's calculated there. The thing that we're calculating is the amount per group. So you could say like having count equal to 2, right? Probably something like that. So these are all the people who wrote 2 movies in 2018. Right? So the having is on an aggregate. Okay? Any questions about this?
So what's the best approach, like join or subqueries? Which is more optimized? Like, I did all these problems through subqueries, and I don't know if like join is like we have to avoid subqueries if we are able to join the tables and do it, or
if you can do the join, yeah, I would say for these problems, yeah, perform the join. Like that's how you'll see it. Like that's kind of the logical approach, and that, I mean, joins like are kind of computationally expensive, but that is the approach that you'll see, and it's like what will make sense to somebody reading this code. So that's what I would do. We haven't really talked about indexes yet, but in Postgres, all of these columns that you join on, every primary key and foreign key by default, in other words, for free, will be indexed, which will speed up the performance of the queries. So yeah, like you want to do this using a join. All right. The only time, when do the subqueries come in? Kind of like we saw, right, with those things that really need to be 2 questions. How many has each of the actors from Toy Story been in? Well, first we need the actors from Toy Story. Then we need to find, get the amount of movies. In other words, if we do a where clause on Toy Story, well, then we're limiting our data set just to the movie Toy Story. So how can we find the rest of those movies, right? That's where we need 2 queries, right? This is where we would need a subquery here. But for this, right, this is different. What is the name of the writer that has been credited the most times during the year 2018, right? Here we're limiting down to 2018, find the writers, find all the movie writers and then put into groups by that writer. Count up every time a writer appears. Okay, other questions about this? All right. The Postgres stuff shouldn't be that bad. I can do like a quick review of that. I mean, the main with the files. Just remember, because I know, if we have like a SQL query, first of all, we can connect to our Postgres database just by doing PSQL, right? By default, it's going to use your username, or at least for me, it does. So, I exit out with a /q. If I want to connect directly to a database that I know of, I'm not sure actually what are my databases. I'm going to list them with /l, and then let's say I want to connect to this Foursquare practice. I'm just going to type q to kind of get back to the console, and then let's get out of here. And now I can connect directly by doing PSQL Foursquare practice. So this command takes an argument, right? Takes different arguments. By default, the second argument is Foursquare practice. You can also put a -d here to specify the database that you want to connect to. So now you'll see that instead of connecting to Jeffrey Katz, we'll directly connect to Foursquare practice. Sorry about that. And you can see that right here, right? So we directly connected to that. And now from here, what do we do? Probably view the different tables, //dt, right? And now you can do something like select all from categories, limit 3, something like that. And you can see, okay, these are the categories of different restaurants. And then finally, if you want to run this, like if you want to, lots of times you'll want to write your SQL code in a text editor. So let's say we have this query, select all from categories, limit 3. You can see from here, I can say PSQL against the database Foursquare practice. I want to run the file SQL query, okay? And then you could say like as the user, if you want to say, put another flag as the user, say like Postgres, or, this capital U is the user flag. And you can see it's running that command. So it's running this file. Yeah, William?
So it's like a little bit intimidating, right? The CLI. Are there any things we should avoid? Like, I'm just kind of afraid I'm going to mess it up somehow, like mess up the whole program. Is that a legitimate fear? And are there any things that I should avoid to, like,
Sure.
Not mess it up?
Yeah, that's a good question. So there's a couple things to keep in mind, One is select statements are not really dangerous, right? Because you're not changing any data with select statements, okay? What is dangerous then? Well, honestly, it's the most common. It's the stuff that you generally do write out in scripts, right? Like what would that be? The create table, whatever it would be, sample table, right? Because this is changing your database. But so normally what you'll do, so the reason, so one, to make this less dangerous, that's you actually write this in a SQL script, right? Why? Because this way you can fix the code, someone can review the code, things like that. So that's kind of one thing is, okay, with the preference is instead of just writing this by logging into the shell and then kind of like, like we typed something incorrectly and press, this and then we, mess something up. It's like better to write it out. That way you can look at it and review it, right? Creating a new table is not that dangerous because there's no fear of losing data, right? And generally what you'll do is you'll put like drop table at the very beginning. So let's say we want to create all of our tables. If say we want to like reset our data set, like reinitialize our database, you'll drop the table first and then you'll create it, recreate it. Now, when does this become dangerous? Of course, it's like in production, like in which case normally you'll never you should like really never do this on production data unless you get a sign off, right? Until you basically get a sign off. Like for instance, in the company I worked in, whenever we were operating on production data, like actually altering it or something like that, we would be like sitting next to somebody from DevOps who like first like signed off on it, right? So that's the fear. The other thing is if you have to move data, like kind of even remove records from a table, like delete where like the person's name is Bob, right? Again, like there you're deleting data. That's what's dangerous, is altering or deleting data. The select statements aren't really dangerous at all because you're not changing data. It's only dangerous if you're accessing information that's private. Like if you hopefully the permissions are set or you don't want to share that data, like literally even like print out any like health information, right? That could be companies can get sued for that. But for select statements in general, they're not as dangerous, right? That's why you'll see like differences between read access and write access, right? Reading would be the select statements. The writing would be, inserting into, and more dangerous, like deleting. So I would say like, that's one thing to keep in mind. And then secondly, when you're doing things like writing or changing data, I think you do want to write out the file first, right? This way someone can review it. You can run it. Generally what you'll do is you'll run it on sample data, see the impact of it, and then run it on production data. And this way you know that you're running the exact same script that you did on the sample data, on production data.
But we can restore the data once it's deleted even. Like a revoke X something. I
Maybe,
forgot it.
yeah, but I mean, I'm sure, there should be like backups and things like that.
Yeah.
But yeah, I mean, you want to be careful. Sometimes that can be time consuming, right? Maybe the data is already in a data warehouse, which is nice. But anyway, you just want to be careful about it, obviously, altering any production data. But writing out the file and then running it, that's something that to me I think that's actually I think of that as less dangerous than any, like you'll notice I'm really only doing select statements from here. I don't really write out the create table statements over here. Okay, that you'll generally do in a script. Okay, it's also nice just to see like what is the schema by referencing this. By the schema, I mean the names of the tables and the columns and the data types of those columns, right? So it's nice to be able to see that in the file that produced those tables. Other things, not too much else I can think of. For this, Oh, one other thing is, okay, maybe I'll show you this. So we're going to do this lab, this like career scraper lab, okay? And you'll notice, basically we'll use the SciCop G2. Same way that we had a SQLite library, there's a SciCop G2 library to connect to Postgres, okay? Now, you can connect to Postgres, like right now, by default, we are connecting to the Foursquare database as the user Postgres, right? On localhost. By localhost, I mean your own laptop, right? You're connecting to a database that lives on your laptop. Now, you can also use this same shell to connect to an AWS computer, all right? So this is going to be PSQL-D connect to the careers database -H. So this is what's different. Connect to this computer, right? This is the IP address of this computer, and you can, I don't know if I can, like it's, I don't know if I'm signed in. Yeah, it might be, probably, but this is my AWS deployed computer, and the way to get to it is this has an address, like my database has